Alright guys, welcome back for the second part of this. So as we work through this, now we're going to talk about graphing. There's not a lot of graphing as far as you actually physically graphing. However, I do need you to understand the characteristics of log functions. So for this first one, what we're doing here is we're going to plug in these values and solve it. So I'm thinking 2 to the what gives me 0. And you would solve it. In this case, that doesn't even exist, so it's not even an answer. We'll talk about that later. The next one, I'm thinking 2 to the what gives me 1/2. Remember, if it's a fraction, it's got to be a negative exponent, so it ends up being -1. We just did a lot of these. 2 to the what gives me 1. In that case, anything to the 0 power gives you 1. And you just work through them. So then you get the rest of the answers, 1 and 2. So I just did all of that, and that's from the section above. So now we're going to talk about, is there a y-intercept? So when x is 0, is there a y-intercept? The answer is no, there is none. So there is no y-intercept. Is there an x-intercept? So when is y 0? And the answer to that would be 1, 0. The big thing for this one, guys, this is used for your transformations. So that's very important to remember. Your domain, as we work through this, your x values, it's going to be 0 to infinity. Your range is all real numbers, which is also negative infinity to infinity. Your asymptote is at x equals 0, aka the y-axis. So that means it's never going to cross that line. This one's 0 to infinity, and then there is no decreasing. So the big thing is the base too. If your base is greater than 1, it's going to look like this. It's going to have this shape. So let's graph this. So 1/2 -1 is right here. 1, 0. 2, 1. 4, 2. So again, if it has a base greater than 1, the general shape of your graph should look something like this. And this dashed line is your vertical asymptote. So now the next one, or the next question that I ask is, if you graph the base functions, the parent functions, what are their characteristics? What do they have in common? So log and natural log, if we do this, both go through 1, 0. That's going to be your x-intercepts. Next thing, both have vertical asymptotes. At x equals 0. And last thing, both are increasing the whole time. However, if I change the base to a fraction, so if it's between 0 and 1, aka base is a fraction, alright, then here's what happens. I still have no y-intercept, however, it changes the way your graph goes. So there is no y-intercept, but I go to 1/2 1, 1, 0, 2, -1, 4, -2. So I still have my vertical asymptote here. It changes the way the graph looks. So now instead of increasing, it's going to be decreasing the whole time. So not much really changes as far as the first 4 things, the domain, the range, the x and y-intercepts, and neither does the asymptote. However, it does change on what it's increasing or decreasing, because there is no increasing, however, it's just decreasing the whole time. So if your base is a fraction, it's going to decrease the whole time. So the next thing, the common characteristics that we usually have. So your domain, if you see a log function, your domain's almost always going to be 0 to infinity, unless we transform it. That's what we're going to do next. Your range is going to be -infinity to infinity. That really doesn't change too often. Your x-intercept is 1, 0. If it's increasing or decreasing, so if your base is greater than 1, it's going to increase from 0 to infinity, and there is no decreasing. If your base is a fraction, then there is no increasing, but it's going to decrease from 0 to infinity. The 0 to infinity is going to go with the domain. Do you see how they're related? They're the same thing, so that's going to change if the asymptote changes. All right, so the last thing, this is what the Hawks is going to be over whenever I assign it, is the transformations. So if you have an A out front, here's what that stands for. Remember, if A is greater than 1, it equals a stretch. We've done a lot of these before, so you got to memorize, which you should by now, hopefully. Should be pretty easy. If it's a fraction, it compresses. And don't forget, if A is negative, it's reflection over x-axis. The next thing, if this is a negative, it flips it over y. If your h is positive, that means it's left. If it's negative, it means it's right. Remember, they're lying to you. And lastly, your k, positive is up, negative is down. So I don't want you to graph on the homework. There's 3 problems like this. I just want you to identify the transformations, tell me the domain and range, and the vertical asymptote. So on this one, what am I going to do? I'm going to shift it right 2 units. Now the next thing I'm going to do is my domain and range. If you move it left or right, that affects the domain. Remember, our domain is 0 to infinity. However, now I moved it to the right, so it's going to be 2 to infinity. Your range does not change. It's all real numbers. And lastly, your C. Where did your vertical asymptote go? Guys, it's with the domain. So if my domain is 0, my vertical asymptote's at 0. If my domain is 2, that means my vertical asymptote is at 2. That's how that works. So now let's do the next one. There's a negative out front, so that's a reflection over x. This tells me I'm going left 1, and this tells me I'm going up 2. Again, guys, the only thing that affects the domain is if you move it left or right. So now I moved it left, so that means I'm going to go to -1 to infinity. My range does not change. My asymptote is based off the domain, so it's going to be x equals -1. I want you to try these last 2 by yourself, but you should see the pattern by now. So this one, my transformations, I reflect over the y because there's a negative, and I move it left 3. So when you do that, it affects your domain. My domain on this one, guys, if you reflect it over the y, this one's a little bit harder. If I reflect it over the y, I'm going to go to -infinity now. So you've got to see that pattern. Your range is all real numbers, which means my domain affects my asymptote. So my asymptote's at x equals 3 because I don't cross that line. So if you reflect it over the y, you're going to go to -infinity now. So just be careful of that. So next problem, my reflection is over the x. I stretch by 3, and I move it down 5. The nice thing is, if you don't move it left to right, your domain and your range do not change from the original one. So it's 0 to infinity, and your range is all real numbers. And lastly, it's going to be x equals 0 for your vertical asymptote. Last problem, I reflect over x, compress by 1/3, and I move it right 1. So that's part A. Part B, my domain is going to be 1 to infinity because I moved it left to right. My range is all real numbers. And then the last part, my asymptote is based off my domain. It's going to be at 1. There's a homework assignment posted on Classroom. I expect you to do all the problems. There's 19 of them. They don't take very long, guys, because a lot of it you're just rewriting the problem like we did in the first part, the first video. From there, if you have any questions, please let me know. You do not have to graph the last 3. So I want you to take a picture of that homework. Whenever you finish it, you can do it on a piece of paper. Make sure you show all your work. and I want you to upload that to Classroom, and that'll be your assignment for the day. Again, if you have any questions, please let me know. Make sure you guys are working on all the homework that's assigned. Try and keep up, because math does build on itself.